Thank you for watching this video. Remember that the best way to study is to take practice tests, and if you can't find good practice tests, build your own and learn while you do it using the Learn My Test study tool. It's absolutely free at learnmytest.com, and you can click in the link below to take a practice test that I made using the Learn My Test study tool. So check it out. Like I said, absolutely free. All right, so we're going to talk about how they make intelligence tests. And don't worry, we're not going to get too far in the weeds. We're just going to talk very briefly. This video is going to be very short. I will do some math, though, I'm warning you, and you don't have to know a ton of math, so don't worry about it. So when they make an intelligence test, what they do is they develop their test, they develop all the questions they want to ask, and then they recruit a sample to take the test that the scores are compared to, right? So if you take your test, an IQ test, your results are going to be compared to a sample that was used to make the test. And so the sample is a stratified sample. So if you can think back to the research methods chapter, we talked about stratified samples. So what they do is they say, okay, we're going to recruit, 100 people that are ages 20 to 35, and we're going to recruit, and of those people that are ages 20 to 35, we're going to recruit 20% of them are going to be African American, because 20% of the people, ages 20 to 35 are African American. So they're going to try to recruit a stratified sample that represents the population as far as ethnicity and all that kind of stuff. So once they do that and they recruit their sample, then they give them the test, right? And they do a bunch of statistics on it. So one of the things they do is they'll get the average score on their tests. So the average score is taken by taking all the scores for that age group, adding them up, and then dividing by the total number of scores. Okay, and then the standard deviation is basically how much the scores deviate or are different from the mean, like how far are they from the average score on average. I know that I'm saying average a lot. Let me show you how the standard deviation is done. So what you can do to do a standard deviation is right here. So let's just say this is my test. I've got 25 people in my sample, and these are my scores here. And so what I'm going to do is I'm going to take an average of my scores. So my average or mean is 6.52. Okay. So what I'm going to do now is I'm going to take the mean, which is 6.52. I'm going to take every score and subtract the mean from it. So I'm going to go ahead and do that here. So I've basically taken, whoops, I don't know why it's doing that. So I'm going to just go ahead and subtract the mean from every score. And so that's what I'm going to do here. And now you've got some, that are negative and some that are positive. So what I'm going to do to kind of fix that is I'm going to square everything. So when you take the square and you multiply a negative by a negative, you get a positive. So this is just a way to make sure all the numbers are positive. And then, so I'm going to get all the square of all the numbers. And then what I'm going to do here is I'm going to get the average of all of these numbers here. So I'm going to take the average of all the squared differences between the mean. And then what I'm going to do is I'm going to get the square root of this number here, because this is squared numbers, and that is your standard deviation. So it's 2.16. So we'll come back to that in a minute, but I just wanted to show you that's kind of how the standard deviation works. So it shows you kind of how far things are from the mean. So just to give you kind of an example there. So this is called a normal distribution. And so a normal distribution is, and so this little circle here is a standard deviation, right? So in a normal distribution, 68% of people are within one standard deviation of the mean. So this is one standard deviation below the mean, this is one standard deviation above the mean. So 68% of the people that take the test are one standard deviation above, one standard deviation below. So then if you look here, 95% of the people are between are between two standard deviations of the mean. So they're between -2 standard deviations below or -2 standard deviations above. And then 99% of people are between 3 standard deviations of the mean. Okay, so does that make sense? Hopefully that makes sense, right? Now every distribution is not standard. Okay, so there's what's called skewed distributions, which means that there's way more scores above the mean than below the mean, or there's way more scores below the mean than above the mean. But in a standard distribution, it's going to look like this, and all IQ tests go on a standard distribution. So let me kind of just give you a little question here. So let's just say you give someone an IQ test and they score 1 standard deviation above the mean. What percentile would they be? So if they scored exactly 1 standard deviation above the mean, how many people have they scored higher than? What percentage of people have they scored higher than? And I'll go back to this. Okay, so you're looking right here, and so this is 1 standard deviation. So this is where they've scored. They're 1 standard deviation above the mean. So they've scored higher than 68% of people here, and then you've got another 15.7, 15.8% here. So you've got 16% here plus 68%. So what's 68 plus 16? That's 84%. So if you're 1 standard deviation above the mean, that means that you've scored higher than 84% of the people that took that test, right? On a normal distribution. What about, let's just say your score is 2 standard deviations below the mean. How many people have you scored higher than then? So it would be 2.1%, right? Because if you're 2 standard deviations below the mean, or 2.2%, sorry, you're only scoring higher than this many people here, right? So that's the idea of a standard distribution. So just a couple of things to know here. When we look at standard scores, there's a number of different types of standard scores. So like the T-score has a mean of 50 and a standard deviation of 10. A standard score has a mean of 100 and a standard deviation of 15. And then a Z-score is a mean of 0 and a standard deviation of 1. So T-scores can be +1, +1.5, 0.75, -1, minus. They're just literally exactly what's on the chart. So that's kind of how a Z-score works. And then there's also, I forgot to point out, scaled scores, which have an average of 10 or a mean of 10 and a standard deviation of 1.5. So that concludes our little brief statistical lesson on the bell curve. So thank you so much for watching this video. Remember, the best way to study is to take practice tests, and if you can't find good practice tests, build your own and learn while you do it using the Learn My Test study tool. Thank you so much for watching.